Okay, so as we have reviewed earlier in this unit, we're going to make sure that we're always doing left side, right side when we set up proofs. So I'm going to set up a left side and right side. Probably don't need as much room on the right side because it's just tan x there. And I'm just gonna flip over here. I don't know why this isn't letting me. Oh, that's the same one, that's why. I'm just gonna flip over to our identity sheet as well. So if you don't have your identity sheet out, that would be helpful to get. Okay, so we always want to have this identity sheet out and ready so that we can kind of look at any identities that we need. All right, so here's our trig identity. The main tip here is we always want to try to get everything in terms of sine and cosine. So I see a tan x here, and we know back from grade 11, and we reviewed it in grade 12 as well, that tan x is equal to sine x over cos x. So I'm going to replace it with that identity. Okay, and then we have a couple of double angle identities, which we looked at last week, which are sine of 2x and cos of 2x. And we need some identities for those ones. So I want you guys all to look at your identity sheet, and I need an identity for the sine of 2x. What would I use? Emma?
2 sine x cos.
Perfect. So if we look at our identity sheet under double angles, sine of 2x is equal to 2 sine x cos x. So I'm going to replace that one with that identity. And we have a couple identities for the cos of 2x. So we can actually choose the one that we want and see if we can make it work. If it doesn't work, we can always go back and we can erase and we can try a different one. So why don't we just try the first one here? We'll see if it works. We have cos squared minus sine squared. Another option here is I'm noticing that this side has sine x on top, and then this side has a cos x on top. So perhaps we might want to choose a trig identity that just has cosine x's, so that I can potentially maybe cancel out some cosines there. So maybe if you notice that, another option that you could choose would maybe a better option that we could choose would be the second identity, which is 2 cos squared minus 1, which I might actually use that one because I'm noticing that on my right side, I don't have any cosines on the top. So something has to cancel somewhere. So let's plug in 2 cos squared minus 1. Okay, and that's just the identity for this guy right here. So we're just plugging that in there. All right, 1 minus 1, that's going to be 0. So that's gone. Now we have 2 sine x cos x over 2 cos squared x. And does anyone see where we can go from here? Okay, I can't see you guys right now when I'm sharing my screen. So just make sure you use the raise hand feature under participants. What can we do from here? Bella?
Can you cancel the 2's and then cancel the top cosec with the squared on the bottom?
Yep. So everything is being multiplied here. So I can freely cancel terms from the top and bottom. The 2's will cancel, and I'll cancel one of these coses with 1 on the bottom. So I'll be left with sine x over cos x, which is actually exactly what we wanted. Now we have left side equals right side. Okay, again, feel free to stop me at any time. Raise your hand if you have questions along the way, okay? Like use the raise hand feature. Okay, next one, we're gonna, again, set up our left side and right side. I don't think we need as much space on the right side as we may on the left side. Okay, and I'm open to suggestions for how we might start something like this. Are there any ideas out there? Look at your identity sheet, see if there's anything that might help us with this. So if we look at our identity sheet, I have a couple things up at the top that are similar to this, but not exactly the same. Sam, do you have an idea?
I was gonna say you can make the left sign equal to negative sine x, maybe.
Where would we, how would we do that? Like, where are you getting that from?
I just read it wrong. Sorry, I read the.
Okay, no worries. Okay, so because we don't have any transformation or cofunction identities that are exactly the same, is there a way that we could expand out something like this? How would I expand something that is like a cos plus cos of something plus something else? Keaton?
Could you make it cos pi over 2 minus negative x?
Yes, we could do
would
that.
make it sine x.
Yep, so that's possible. So one way that we can solve this is we can use that little trick that we did in some of our previous lessons. So if we see something like this, for instance, this format is very similar to what we have in our proof. So that's a good idea, Keaton. The other option is, yeah, Sirwa?
You could use the compound angle identity, like the cos x plus y.
Yes, so this is the other option. We can actually do this proof either way. So Keaton, because you suggested this first, we'll go with this proof, but be aware that you can, you know what, maybe we'll just do both. We'll show both. So yeah, we can create a subtraction here by doing pi over 2 minus negative x. And the minus a negative, that just goes back to plus, right? So we haven't really changed this in any way. And then when we create an identity, if I plugged in negative x here, I plug in negative x here. So this will be equal to the sine of negative x using that cofunction identity. And what do we know about the sine of negative x? Because sine is an odd function, what will this be equal to? Sirwa?
Negative sine x.
Yes, so using our even and odd identities, sine of negative x equals negative sine x because sine is odd. So this will be negative sine x. Okay, the other option, which is what Sirwa suggested, is that we use this cosine compound angle identity, which is, it will expand out into cos of the first thing times cos of the second thing minus sine of the first thing times sine of the second thing. So I could also have done cos of the first thing times cos of the second thing plus sine of the first thing. Oh, sorry, it's actually minus minus sine of the first thing times sine of the second thing. And what we would actually do here is we can actually evaluate these two guys here, and cos of pi over 2 is 0. So we end up getting 0 times cos, and sine of pi over 2 is actually 1. And what ends up happening is this term is gone because 0 times anything is just 0. And then this is negative sine x. So either one of those proofs would have been an acceptable proof. Okay, this would be option 1 and option 2. Okay, any questions on that one before we move forward? Okay, I just want to remind you guys as well, when you're doing your proofs, just make sure that you set up proper formatting. So you're always doing left side and right side and splitting them up. We don't cross over, so I don't take something from this side and move it onto the opposite side or anything like that. And then I'm always making sure that every time I do a new step, I have equal signs to separate out all those steps. Makes it a lot easier to read. Okay, and then of course at the end we have our final left side equals right side. All right, we're going to do 2 more and then you guys will have some time to practice some of your own. So we are going to prove the double angle. Amelia, yeah, sorry.
Why was it a 0?
Well, you can check on your calculator. If you type in cos of pi over 2, you're going to
Okay.
get 0 on that. Or you
Okay.
can just use like the key points of cosine. Like cosine has, if we look at the cosine graph, cosine starts at 1 and ends at 1, and at pi over 2, the y value is 0 for cosine. That's an x-intercept of cosine.
And cos x and sine x just didn't matter, just because.
Sorry, can you clarify your question for me?
Like, where did cos x and sine x go? Or sine pi?
So
Oh, never mind. Okay, I understand.
you got it?
Yeah,
Okay.
okay.
All right. Okay, so we're going to actually prove the double angle identity for tan. This is on our sheet, but we never use an identity to prove itself. So we're going to see if we can use this identity for tan, or we're going to use other identities to prove the one for tan. All right, so we have taken some time in our previous lessons to prove the double angle identities for sine and cosine. So I'm going to use actually the identity that we used earlier, which is that tan is equal to sine over cos. And if I have something like the tan of 2x, that just means that this will be equal to the sine and cos of the same thing. So sine of 2x over cos of 2x. As long as the insides match, the identity still holds true. Okay, so we can go a little bit further with this one, but I'm going to suggest that maybe we work a bit on the right side until we figure out what we need on the right side to decide where we want to go on the left side. So I'm going to actually go through here and I'm going to replace tan x with sine x over cos x. That's the tan identity. 1 minus tan squared x. If I check my Pythagorean identities, I have a 1 plus tan squared x, but I don't have a 1 minus tan squared x. I don't have any other identities for that one. So we're going to have to again use the fact that tan is equal to sine over cos. So I'm going to replace tan squared with sine squared over cos squared. Okay, remember we can always, if I have that tan x equals sine x over cos x, I can always square both sides of this. As long as I do to one side what I do to the other, and then the squared will be applied to both sine and cos. So that's where we get this guy from. Okay, so I want to clean up this right side a little bit here. I'm going to think of this as 2 over 1. So when I multiply that in, I'm just going to get 2 sine x over cos x. That's the top. On the bottom, if I have two things that are being subtracted here, and one of them is a fraction, I think I'm going to need a common denominator on that one. So I'm going to multiply this by cos squared on top and bottom so that I can put these together in one single fraction. That's the only way I'm really going to be able to simplify anything here. So I'll have cos squared minus sine squared all over the common denominator, which is cos squared. All right, so we have a fraction over another fraction. We are going to take the second fraction and we'll flip and multiply. So flip, and then you can change to multiplication. All right, I'm seeing we have a cos x and a cos squared x. I'm going to cancel a cosine out of each of those. So I'll just be left with a cos x on top. I cannot cross cancel or cancel up and down with this denominator on the right, because this denominator on the right has a subtraction sign here. So I can't cancel individual pieces of that. So as far as canceling right now, that's really all that I can do. I'm just going to put together the tops and bottoms now. I have 2 sine x times a cos x, which is 2 sine x cos x. And then on the bottom, I have cos squared x minus sine squared x. And if I look at where we're headed over on the left side here, these look like we could actually just sub in the double angle identities now for sine and cosine. And we can have left side and right side equal. So I'm going to use the double angle identity for sine here, and I'm going to use the double angle identity for cosine, and we're just going to sub those in. Okay, you can do it actually on either side if you want to. If you don't have any room left on the right side, we can actually just plug in the identities on the left side here. Okay, and now we have left side equals right side. For some reason, this isn't letting me erase this. Oh, well, that's okay. Okay, any questions for this one that I can clarify? Keaton.
Why do you multiply the top and bottom by cos squared x?
So I was doing 1 minus sine squared over cos squared. And in order to put these two things together here, I needed to create a common denominator. So that's why I multiplied the top and bottom by cos squared. Otherwise, I wouldn't have been able to get this like single fraction over here. Any other questions? Okay, last one. I don't think we'll need as much space on the right side here because we just have a sine of 2x. All right, so we've got our proof set up. I'm going to use the double angle identity for sine again. So we've been using this one a lot this lesson. Sine of 2x is equal to 2 sine x cos x. And then we've just proven the double angle identity for tan, so we can use that double angle identity. This is our ultimate goal, is that we want the left side to be equal to 2 sine x cos x. I also just want to remind you guys, because of BEDMAS, we can't subtract these two things. That's because the second thing is being multiplied by sine squared x. So there's not a ton that we can do here. One option could be that we could take out the tan of 2x from each term and maybe see if that simplifies things a little bit for us. So I'm actually going to common factor a tan of 2x out of each term. What would be left after I take the tan of 2x out of each term here?
2 tan x sin squared x.
So I would have taken this whole thing out and this whole thing out. So I'm dividing each term by tan of 2x when I common factor. So what's tan of 2x divided by tan of 2x? Serena?
You'll be left with -2 sine squared.
Okay, and what about the first term? What happens when I divide tan 2x by tan 2x?
It'll just be 0
What's anything divided by itself?
or 1.
All right, there we go. Thank you. That's good. Okay, this step actually simplified things for us a lot, because this right here, if we look at our sheet, does anyone see a trig identity that we might be able to use for 1 minus sine squared x? I'm just going to erase all this here. Or 1 minus 2 sine squared x, actually.
The cos and the double angle identities, the cos 2x. Yeah, there.
Cos 2x, perfect. So that's actually really nice, because we can now just do tan of 2x, and I'm going to replace this guy with its identity, which is cos of 2x. Okay, so just as a reminder, this step was we common factored out the tan of 2x. So if you want to write that for your future self, if you're looking back. Okay, any ideas for how we can finish this proof? We're about 1.5 steps away here. We're like very, very close. Yuri?
Can you change tan 2x to sine x over cos x?
Yes, but not sine x over cos x, would be sine of 2x over cos of 2x. But yes, great idea. So now we have the identity in there. And we should be noticing now that I have a cos of 2x on a top and on a bottom, and they can be canceled. And that's actually equal to the sine of 2x, which is actually our right side here. So we actually didn't even need this. We can just erase this, this step right here, because I can't erase right now. I'm just going to plug in 2 sine x cos x, which is the double angle identity, and then we're done. Okay, any questions that I can clarify for this guy?